All right, good morning, everybody. Afternoon, whatever time it is. I'm on the trip apparently, maybe still on the way back, but let's go ahead and get started on our tangent rule just so you can see it. My apologies that's kind of covering things up. So here is our tangent rule. A couple things I want you to notice, please. When we add in the top and subtract in the bottom. When we subtract in the top and add in the bottom. And that's kind of because I think I mentioned this one day, tangent is like sine over cosine. And remember, for sine, we kept the sine SIGN the same, but for cosine, we switched the sine SIGN. If it was positive, it became negative. So I don't need to wait around. If you need to pause this right now, pause it for a moment till everybody's ready, but I'm going to click to the next screen and we're going to start on the next problem. I am going to have to move things because where I put this problem. So tangent of 75. We could go through and we could try to figure out what things are what, but it's going to work the best if I just kind of go through this first example. So let's look at this. Oh, my fault. So the tangent of 75, of course, two things, we could do 30 and 45. But the way I started to write it, we're going to pretend we're doing 45 for alpha and 30 for beta. Okay, so if you need to look back up at your formula, but we're going to add again in the top. So we're going to write the two tangents added in the top. And then we're going to subtract in the bottom. But the two tangents happen to be multiplied. Okay. Tangent of 45 using the back unit circle is 1. I'm going to write that as a 1 like this right now. I don't know why. Tangent of 30 is radical 3 over 3. Since we picked things in the first quadrant, we don't need to worry about whether they're positive or negative. Then we have 1. And then since I already did these two guys, you don't have to think about it. Then we're going to have 1 times radical 3 over over 3, excuse me. So I am going to start writing this down, but then I'm going to talk about something I know we talked about one day in class. Radical 3 over 3, 1 times anything, right down here, 1 times anything remains itself. So we're going to have minus radical 3 over 3. But I believe one day in class, we talked about if we have fractions with fractions, we want all of the denominators to be the same. So does anybody know, I'll kind of use this highlighter point to show you, what our denominator is. And does anybody know a very particular way to write 1? 1 can be written as almost anything we want. 5 over 5, 8 over 8. It would be very convenient to write this one as 3 over 3. Hopefully everybody in the room agrees 3 over 3 is 1. Because now that I have the same denominator, I can actually kind of pretend everything has a fraction. They all have the same denominators. They are not there. So now I'm going to have 3 plus radical 3 over 3 minus radical 3. If you were in my class last year, this was called the conjugate. If you weren't in my class, you still probably called it the conjugate. But this is where I let kids in my class cheat and do the FL method only. Remember, the conjugate is where you flip from a negative to a positive, or if this original right here would have been a positive, you would flip it to a negative. Whatever is in the bottom of the denominator has to be, in this black fraction I'm writing in right now, has to be the same. So these two fractions over here have to be the same. These do not. This is what our work gave us. But in order to rationalize the denominator, the reason I get to say FL only is because if we would do the full FOIL method, the reason we pick conjugates is because the middle terms cancel out. So we're only going to do F, which stands for first, which is 3 times 3. That gives us 9. We're only going to do L, which is a radical 3 times a matching radical 3. Matching radicals give us just a normal number. And if we cheat and do the FL only, they will always be subtracted. However, in the top, since they're not conjugates, we have to do the full FOIL method. Bear with me. F stands for first. 3 times a 3 gives you 9. O stands for on the outside. Look at my little pencil tracing here. A 3 times a radical 3. You can't really multiply those together besides writing 3 radical 3. On the inside, Technically, it's the other way, a radical 3 times a 3, but you cannot add those, multiply those together, excuse me. So we're going to get 3 radical 3. And then the top, we do have 3 times a radical 3 times a matching radical 3. That is going to give you another normal 3, but the red one is a plus, the black one is a plus, a positive times a positive is still a positive. Now, we asked this question yesterday, when can we add radicals? When they are the same. So guys, I hope you noticed that up in the top, the 9 is a normal number, the 3 is a normal number. In the bottom, both 9 and 3 are normal numbers. So I'm going to kind of circle those in that blue because they're all similar. But then this has a radical 3 and this has a radical 3, so I can actually add those. So in the top, I'm going to get 9 plus 3, which is 12. In the top, I'm going to get 3 plus 3, which is 6. But that 6 has a radical 3 on it. And in the bottom, I'm going to get 9 minus 3. 9 minus 3 is 6. But when I want to reduce a fraction that has radicals in it, I ignore the radicals. So I'm going to scribble this guy out for a minute. If you had a 12 and a 6 and a 6, you would tell me, hopefully, they reduce by 6. And you would cross out the 12 and make it a 2. You would cross out the 6 and make it a 1. You would cross out the 6 and make it a 1. I never have to actually write divide by 1. I never actually have to write times 1. So my answer is going to be 2 plus radical 3. All right, so that was for the tangent of 75, okay? For the next one, I'm going to pick 120 and 45, okay? We could have paused it again. I want to go through one that has a 60-degree angle in it because 120 is like a 60-degree angle. Last one had one that was like a 30-degree angle. So again, 120 and 45. Once again, I might be going kind of fast if you need to pause and go back or whatever. We're adding again. So in the top, we're going to add tangent of 120. We have to be careful now because what quadrant is 120 in? Yep, it's in quadrant 2. So we have to be a little bit careful because we're moving in a different quadrant. Therefore, tangent might be positive or negative. What quadrant is tangent positive in? Yes, tangent is positive in quadrant 3. So the tangent of 120 degrees is like a 60-degree angle. A 60-degree angle has radical 3. But as I just mentioned, 120 is in quadrant 2. Therefore, that's going to be negative. Tangent of 45, still 1. Tangent of 45 is kind of nice because you're going to get 1s. So in the bottom, I'm going to get 1 minus, and then those exact same 2 answers multiplied together. I'm going to do the next step right here, I think, kind of like I did before. We can leave it this way, guys. I'm going to leave it this way, but if you really want to, you could write the 1 first and then the radical 3. In the bottom, obviously, I have 1. These 2 multiplied together gives me radical 3, but since I have a negative and then just 1 more negative, sometimes there's a possibility they could be both. In the bottom, I'm going to get 1 plus radical 3. Some people like to fix this because they feel like it's out of order if 1 is a real number and then a radical number, but I'm going to keep it that way. Of course, I need to rationalize the denominator. Uh-oh, my pen disappeared. Give me a second here. There it is. So I'm going to do the denominator. But I have, this time it's a plus, so I have to switch it to a minus. So I am going to leave the numerator as negative radical 3 plus 1. I'll put that in parentheses because it will be helpful in a moment. The denominator, I'm going to copy down as 1 plus radical 3. Sorry, since I switched colors again, let me switch one more time. The conjugate of the denominator would be 1, but then I'm going to change it to a plus, from a plus, excuse me, to a minus. So 1 minus radical 3. And since that's what's in the bottom, that's what has to be in the top. Again, start to learn the FL method only. 1 times 1. Radical 3 times radical 3. Since 1 is a plus and 1 is a minus, that's why FL only always gives you minus in the middle. Negative radical 3 times 1. I'm doing the full FOIL method in the top. Negative radical 3. A negative radical 3 times another negative radical 3. They're both negative, so I'm going to get a positive regular 3. A 1 times a 1 gives me a 1. And then the 1 times the negative radical 3, that's going to be negative radical 3. Look for like terms in the top. I am going to go in order now. I see a 3 and a 1. I'm going to circle those. I'm still using just the same color right now, guys. But that's going to give me a 4. And then let me squiggly overline. That's kind of a weird thing to say, but since my pen is up there, those are both radical 3s. So technically a -1 and another -1 would give me -2 radical 3s. In the bottom, 1 minus 3 is -2. Again, if I kind of for a moment ignore that radical 3, these would all reduce by 2. And technically, I'm going to reduce them by a -2 because of the negative in the bottom. 4 reduced by -2 would give me -2. 2 reduced by -2 would change it to a +1. -2 reduced by -2 would change it to a +1. Once again, I don't have to write divided by 1. So my final answer for this one is -2 plus radical 3. And as we kind of mentioned the other day, since these answers are, since these problems are all kind of the same, and we're going to talk a little bit more about that, that is why I had as my first answer in the black box there towards the bottom right, I had a 2 and a radical 3 in my answer. This time they both happen to be positive. This time in my answer, I had a -2 plus a radical 3. One of them is negative, one of them is positive. That is pretty much how it will work out if you are doing tangents. Hopefully, when you reduce them and do the work, you will always get a -2 and a radical 3, whether they're positive or negative, depends on the problem. So once again, and hopefully a little bit here right now, Mr. Thompson, I think, was the only one who had this video. Hopefully it will be shared to Google Classroom shortly, and you will be able to watch it by yourself, or you can always go back as a class. But there should be a worksheet with about 3 to 5 problems on that should be handed out pretty soon that you should work on. Please hand that in to Mr. Thompson before you leave the room today. Thank you.